Hello and welcome to my channel. I am Mensa Augustine. In this tutorial, we'll be looking at the derivative of sine x from the definition of derivatives, or we'll be looking at the derivative of sine x from first principles. Now you know that from first principles, f prime of x is equal to the limit as h approaches 0, f of x plus h minus f of x divided by h. So here let's take sine x. If we take sine x, then f of x plus h is simply writing sine and then replacing x by x plus h. And now our f of x is equal to sine x rather. So now let's see. Here f prime of x will be equal to the limit as h approaches 0 sine bracket x plus h minus sine x divided by h. Now this is the same as the limit as h approaches 0, then we expand sine x plus h using the double angle formula. That is the sum angle formula for this. We have x sine xh cosine h plus cosine x sine h minus sine x divided by h. So what we do is that we have sine x minus sine x, so let's put them together. So we have the limit as h approaches 0 sine x cosine h minus sine x plus cosine x sine h all divided by h. And this is the same as the limit as h approaches 0. Factorize sine x out, you have sine x into bracket cosine h minus 1 plus cosine x sine h all divided by h. Now we're going to have the limit as h approaches 0. We have sine x dot cosine h minus 1 divided by h plus cosine x sine h divided by h. Now since we are finding the sum, we can take the limit of this and then take the limit of this as h approaches 0. So let's take the limit. We are going to have f prime of x to be equal to the limit. Now before we take the limit, let us look at something. Here as h approaches 0, sine x becomes a constant. So you factorize sine x out. So you are having sine x out, then we take the limit as h approaches 0 cosine h minus 1 divided by h plus, here to cosine x is a constant, so we take plus cosine x, then the limit as h approaches 0 sine h divided by h. Now if you take your calculator, here we are saying that as h approaches 0, not necessarily becoming 0. So let's take that h equals 0.000001. That is, h is approaching 0. So take your calculator and point cosine of 0.12345. Okay, let's take 5. 1, 2, 3, 4, 5, 1 minus 1 divided by 0.12345 and see what you get. So cosine of 0.12345 minus 1 divided by 0. You see that this one will be 0. Very simple as that. This one will approach 0. So as h approaches 0, cosine of h minus 1 divided by h will approach 0. So you are going to have this as a sin x times 0 and plus cosine x times 1. If you put h to be equal to 0.0001 into this one, you see that sin h over h will also approach 1. However, there's a geometric proof to this, but for the sake of this proof, let us take it this way. Now, we are going to have this to be equal to sin x times 0 is 0 plus cosine x times 1 will give us cosine x, and we have proved that from the definition of derivatives, or from first principle, the derivative of sin x is equal to cosine x. Thank you for watching. Please subscribe to my channel and don't forget to touch the notification button for more videos. Bye bye.